Okay, so moving on to question number 9. Water is known as a polar molecule because, and then it gives us different options. So first I'm just gonna write down the water molecule before we get into the specific options that they give us, just so that we're all on the same page. This is the water molecule. And oxygen is more electronegative than these two hydrogens. So I'm going to draw that it has a dipole moment going in the direction of the oxygen. Let me also put in the lone pairs here. So because oxygen is more electronegative than the two hydrogens, the molecule has a slightly negative side. And then on the side with the two hydrogens, they're partially positive. So this is the reason why water is polar. Let's look at all the different options that they give us. They have 1, the oxygen atom has a greater attraction for electrons than the hydrogen atom does. So this solution is correct. The oxygen and hydrogen atoms have the same electronegativity. So we know that this is false, since oxygen has a higher electronegativity than the two hydrogens. 3. Water has two hydrogen atoms covalently bonded to a single oxygen atom. So this is true, but it's not the reason why it's polar. I don't know if it's a trick question, but I'm just gonna say true. But not a reason why it's polar. For the electrons of the covalent bond are not shared equally between the hydrogen and oxygen atoms. So this is true. And it's also one of the reasons why water is polar. For 5, the hydrogen atom attracts electrons much more strongly than the oxygen atom. So again, we know that this is false, since O2 will attract them more strongly. And then let's look at the last option. Water dipole moment is equal to 0. So this is also false, since water has a non-zero dipole moment. So dipole moment is kind of similar, but it's the same thing as the arrow that I drew up here. You'll see that it's pointing in the direction of the oxygen. So if we had a non-polar molecule, I'll just show for comparison. Not only do they all have similar electronegativities, but also the hydrogens are all pointing symmetrically in like different directions. So this is an example of a zero dipole moment, since they all cancel each other out. So this CH4 is a non-polar molecule. Let's see the answer from our junior tutor. Sorry. Can't see that. Okay. They said the correct statements are that oxygen atom has a greater attraction for electrons than the hydrogen atom does. Yep. And then electrons of the covalent bond are not shared equally between the hydrogen and oxygen atoms. So that is also correct. So this solution is correct.